Laurelton Hall Physics Girls. Laurelton Hall Physics Girls. Physics, 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 physics. Laurelton Hall Physics Girls. Miss Hinton's rules. Laurelton Hall Physics Girls. Laurelton, 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 Laurelton Hall Physics Girls. Physics, 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 physics. Laurelton Hall Physics Girls.
Laurelton Hall Physics Girls! In the bubble gun, work is shown on the trigger. Work is being applied on the trigger when the finger pulls it back, which causes the bubbles to be released. W equals FD. So in order to find out, you have to multiply F and D together. So the work increases the more force is applied. So the harder the trigger is pulled is equal to the more work being done. A real-world example of work is a hunter whose gun is exerting 50 newtons and shoots 145 meters. So the work being done would be 7,300 joules of work.
The next concept shown is centripetal velocity. In the bubble gun, the centripetal velocity is shown on the fan inside. You pull the trigger and the fan spins around in a circular motion, allowing the bubbles to come out of the hole. The fan inside is constantly changing direction and accelerating, resulting in the centripetal velocity. To find centripetal velocity, you need to use the formula V equals 2 pi r over t. The V is for the centripetal velocity, the r is for the radius from the center to outside, and t is the time. A real-world example for something with centripetal velocity is a Ferris wheel. Though it doesn't move as fast as the fan in the bubble gun, it is still going in a circular motion. It's always changing direction. Let's say that the radius from the center to outside is 10 meters. And the time for the Ferris wheel to go around once is 5.8 seconds. Your centripetal velocity is 11 meters per second.
Look closer at this spring. It goes in and out and gets longer and shorter, bigger and smaller, right? That is the compression and elongation of the spring. In this toy, the spring starts at a natural and rested, and each time the trigger is pressed down, it compresses the spring, which pushes back on the fan, which then rapidly rotates and pushes the bubble out. Therefore, it consists of spring constant, which can be calculated. As an equation, Hooke's law can be represented as F equals Kx, where F is force we apply, K is the spring constant, and X is the extension of the material. Let's do a real-life example of a spring constant mathematically worked out. Let's say that a girl on a pogo stick applies 420 newtons on the pogo stick. And the spring starts out at 0.3 meters and then compresses to 0.12 meters. So you would subtract that
Caroline,
to find the spring constant. So you would subtract 0.12 from 0.3 to find the distance of the spring. That gives you 0.18 meters. That's the difference that you will use as the extension or compression of the material. That means that the spring constant would be, and with sig figs, you would make it 2,300.
Period and frequency are shown in the bubble gun when the fan inside spins around several times. Period and frequency include time and revs. When the fan spins around, it goes a certain number of times in a specific time.
the formula for frequency is the number of revolutions over time. Now, the formula for period is frequency is the number of occurrences of a repeating event per unit of time. The period is the duration of time of one cycle in a repeating event. So the period is the reciprocal of the frequency. For example, let's say a Ferris wheel goes around 10 times in 58 seconds. The period would be 5.8 seconds, and the frequency would be 0.17 hertz. As you can see, to break it, we took off the top, broke it in half, and took out the inside spring and fan. We pulled off the inside, and as you can see, where the trigger is, there's a spring attached, which causes the bubbles to come out. And above there, which causes them, the spring causes the fan to move, and the fan rotates. That's the fan.
Well, now who's going to fix it? Miss Pinson spent a whole $1 on it at the dollar store. She's gonna be so mad.
Don't worry, I got this. As you can see, I am taking the white part with the fan and spring and putting it back in between the pink outer part of the gun and pressing it together. I then take the yellow part of the gun and put it back on. This is where the bubbles come out. As you can see, I am demonstrating to show that the gun still works and functions.
Good job, girls. You fixed it and made it work. You deserve an A.